Dear students and participants of the course on railway engineering, today in this lecture we will be giving a focus to the speeds on the railway tracks. If you remember, in the previous lecture we started this module and we discussed about the track alignment, and in that we talked about the needs, we talked about what are the various requirements, and then finally what are the factors which should be considered when we are selecting a profile between the two locations which needs to be connected. Now once that is being done, the another thing which needs to be taken care of is the speed. What speed should be there on a track? When we talk about this speed, are there any effects of the speed on the track? What are the various definitions related to the speeds of the trains which are moving on the tracks? And out of those, two of the type of speeds which are of quite importance, which will be considered again and again, they are a safe speed and a permissible speed. And finally, we will be talking about the speed restrictions also. So let us start with the discussion on speeds. Now speed on track, they have been classified by the classification of the tracks. So if you remember this classification of the track we discussed previously, that was from group A to group E. In the case of group A, the speeds are up to 160 kilometers per hour, but when you talk about group B, it is 130 kilometers per hour. Group C is related with the suburban sections. So these suburban sections are available in the big metropolitan cities. Group D, we have two categories, normal and a special. In the case of a special, the speeds up to 110 kilometers per hour are being provided, and here the traffic density is more than or equal to 20 GMT, gross million tons. But in the case of D, though the speeds will remain the same, but the traffic density, it is reducing, it is less than 20 GMT. And in case of group E, all different sections or branch lines will come into this, where the speeds are going up to 100 kilometers per hour. So this is one idea regarding how the various speeds are going to be there on the different categories of tracks. Now just try to understand that what we have discussed so far in different lectures, wherein the speed has been talked in one or other form in combination with other things. We talked about the track structure, and the track structure we did talk about 110 km per hour speed to 160 km per hour speed, and that was then discussed again under two subcategories, that was 110 to 130 and 130 to 160 kilometers per hour. And there we did talk about that what should be the height of the ballast cushion, what should be the formation width, what should be the slope, what should be the cess. So all those different aspects were correlated with these speeds. Another discussion was related with the industrial rails, IU rails, which are mainly used in the industrial area, where the speeds restriction can be up to 50 kilometers per hour. We also talked about that the speeds are going to be specified with respect to the rail sections going to be used. If you are talking about the lighter rail sections, the speeds cannot be high. For that you need a heavier rail section. Sleeper density also is correlated with the speed, and these things are being covered when we talked about the track structure. Similarly, about the ballast cushion. Then we said that yielding formations, if they are there, then in that case the speed should be restricted on that, and first of all the formation should be treated, then only the speeds can be increased. And the speed restriction is going to be followed even in those cases where the welding is being done between the two rails, and the speeds can come to the normal conditions even after 30 minutes of time, or if the grinding operation is going on, then in that case also the speed should be reduced. The grinding operation will come when? If you remember, we did talk about the corrugation on the rail head. Then the same is followed during the closer rail insertion. If there is a gap between the rails which has come up, or there is some section which is being removed because of the wear or because of the failure or the fractures, then the closer rails will be there, and when this operation is done, then also the speed restriction will be there. Speed is also restricted when the rail is cut, or when the special fish plates or the screw clamps are placed if the track has buckled. Then we talked about the major maintenances, lifting, alignment, deep screening, sleeper renewals in all of these cases, and even in the cases where there are different temperature zones and a temperature goes beyond certain limits, the speeds needs to be restricted. Temporary speed restrictions sometimes needs to be followed, and they were followed and were discussed when we were discussing about the long welded rails or the continuously welded rails. In those particular tracks, when the joining of the rail ends is being done with 1 meter long fish plates and the special screw clamps, as we just discussed in the previous slide too. So, at that time when this operation is being done, the speeds are restricted. There is a speed restriction of 30 kilometers per hour during the de-stressing operation of LWR. Speed restrictions are also imposed when there is a track maintenance and repairs due to rail failures. Now, let us look at the effect. There is a dynamic effect of the speed. If you see here on the diagram, say this is a wagon or a vehicle, you can, whatever the way you want to define, you can define it. So, this is x axis, the y axis here and z axis on this side, and say the train is moving in this direction towards the right hand side. So, what are the possibilities which can happen? So, there can be a rotation about an axis or there can be a movement about an axis, and those are the things that are being defined here. So, if you look at on the x axis, if it is rotating with respect to the x axis, then that is defined as rolling. It means it is moving in this form. So, taking oscillations like this. When you talk about y axis, then it is pitching, that is the rotation which is about the y axis. So, sometimes this goes down and this goes up, or sometimes this goes down and this goes up. So, that sort of a pitching condition will be there. Then in the case of Z, that is known as nosing. So, rotation is known as nosing. That means there is a possibility that it will be moving in this form with respect to the z axis. So, the movement can be like this, the movement can be in this form, the movement can be in this form depending on which particular axis we are talking about. Similarly, this movement can also be along the axis. So, if it is along the axis, it is known as shuttling. If it is along the y axis, then it is known as lurching. So, that means along the x axis, it means the train is though moving, but still between the wheel heads there is a movement of the wagon. And when you are talking about the y axis, this is possible because of the lateral movement of the bogie. So, there is a gap between the flange and the head of the rail, and because of the lateral forces, if it moves in this form, so that is a lurching which will be there. Similarly, in the case of Z, if the wagon goes up and down on the track, so that is bouncing. So, we have 3 rotational cases and we have 3 the movement cases along the axis. Now, once we have discussed about that, the another thing which may happen is the resonance. Now, this resonance will be at this level where the wheel and the rail, they are in contact with each other, and when the train moves at a faster speed, so those vibrations or the frequencies gets induced and they will get transmitted to the rail head. So, there is a sort of resonance which will come, and because of this resonance there is a possibility that the rail may failure. If it goes into failure, you have to go for a maintenance. So, in the case of high speed rail systems, this resonance becomes a one important aspect which needs to be taken care of, and that is accordingly the material selection has to be taken up. Springing action, that is again related with the vehicle. So, what type of springing is being provided, accordingly it will happen. Suspension characteristics, again that is also related to the bogies. So, these are also going to be induced because of the speed on the track and the irregularity of this track in terms of the profile, in terms of the formation which is being provided at the bottom. So, accordingly these type of effects will come. Say here we are looking at the three of the effects like rolling, bouncing and lurching. So, rolling means we are talking about with respect to the x axis the rotational movement, bouncing is we are going up and down in the z axis, and lurching means we are going along the y axis. So, it may be a normal condition which is being shown here, but it may happen in this form that it starts rolling, that in one side the height has increased, in another side the springing action height has gone down. So, it is a rolling action which is happening with respect to the x axis. Whereas in bouncing what happens is it is going up and down, or in lurching it is going left and right. So, this is how you can see the conditions may happen. Then another two effects which are being shown here, this is pitching and nosing. Nosing means we are talking about vertical axis, and then there is a rotational aspect with respect to the z axis, and the case of pitching you are talking about the y axis and the movement of the train in a rotational form about the y axis. So, here also you may find that this is how the movements may take place. Now, let us talk about some of the definitions which are related with the tracks, and they are going to be computed as a part of the geometric design and calculations. First one is maximum permissible speed on the track. Now, this maximum permissible speed on a track is the speed which is being provided or allowed for the operation of the trains based on the structure. What type of structure is there, what type of formation is there, what type of ballast cushion and the thickness of the ballast cushion is provided, what are the types of sleepers and the rail sections are being used accordingly. This maximum permissible speed on the track can be defined. One aspect which we use is an average speed of the trains, and this average speed of the trains is finally being used to calculate the equilibrium speed. We will see about that. So, it is a journey speed which is dependent upon the length of the route and the time taken by the train to cover that route. And when we talk about this, it means the stoppages on the different stations will also be taken into considerations, and that is where this is an average speed. It is not a running speed. In the case of running speed, then you will not be talking about those stoppages. The maximum sanctioned speed on the track, this is a speed which is being sanctioned by the track engineer, and this is sanctioned only under the emergency conditions. So, that speed is a sanctioned speed, and this is always notified for each type of track, for each type of a section. It is determined based on the standards of interlocking, the type of locomotive which is being used and the type of the rolling stock, the condition of track. Considering all of these aspects, the track engineer will take a decision and will define that what is the sanctioned speed which can be there on this track, up to which the train can move subjective there is an emergency condition. Safe speed on a track. Now, safe speed on a track is it protects the carriage from danger of overturning on the derailment and provides a margin of safety. So, it is obviously lesser than the maximum permissible speeds or the sanctioned speeds. So, up to this speed, it is assumed that the movement of the train is going to be safer, comfortable. As you start going beyond it, then only there are possibilities of some more forces or dynamic effects which will be there, and because of that some issues may occur. As I said previously, when we were talking about the average speed of the trains on a track which are used for finding out the equilibrium speed. So, equilibrium speed is also defined in another form with respect to the centrifugal forces which are going to be induced on a curved track. So, on this curved track the centrifugal force is being induced, and since to counter that we have to provide a cant. So, there will be a cant which will counter the centrifugal force. So, at this particular cant, whatever the speed is, that particular speed is being defined as an equilibrium speed. Now when you talk about this speed, not all of the trains are going to move on this equilibrium speed. We have talked about some value of cant because of this centrifugal force which is related with the speed of the movement, and that is where we say it is mv square divided by r, where r is the radius of the curve. Now when the train is moving at a speed lower than that and a speed more than that, then this cant that is going to change into a cant excess or cant deficiency, because if it is a lesser speed then this much cant will not be required. So there is a the cant which is equilibrium, but the cant which is required, say if it's we say it is CR, then there is a difference between it. So CR is lesser than the equilibrium cant, and when the speeds are more, then we will be requiring another cant which is extra required, say, and it is going to be more than this. It all depends on the high speed and the low speed on the track with respect to this equilibrium speed. So probably you have understood that how the excess or the deficiencies are there. So in this side it is defined as excess, here the deficiency will be there. Maximum permissible speed of the curve. This is the highest speed which will be permitted on a curve, taking into consideration the radius of the curvature, actual cant, cant deficiency, cant excess, and length of transition. So what I was talking here, everything is going to contribute to find out this maximum permissible speed. We have to consider what is happening with respect to the speeds which are moving at a lower speeds on this track as compared to the equilibrium speed of the trains which are moving at a higher speed. What is the radius? What is the cant which is actually being provided? And on the basis of that we will get certain values, and out of those values one will be taken as a maximum permissible speed. Now this equilibrium speed, this is decided based on the maximum permissible speed which is defined by the track engineer Vm, where m is the maximum. Then permanent and temporary speed restrictions which can be there, they are defined by the traffic controller. The number of stoppages, and these number of stoppages they are defined on the basis of the way the profile was finalized, and that profile was finalized considering the revenue which can be generated, or the possibility of the gradients, they may or may not be there, and the proportions of the slow and the fast trains. And this slow and the fast trains, when we are saying, we are talking with respect to the equilibrium speed. So anything lesser than that is slow, anything more than that is faster. Now safe speed, it is limited by the maximum speed defined for every train, as well as by the vehicular characteristics which differ within different categories of trains. So these two things has to be taken into consideration. So what type of a rolling stock is being used? Not each and every rolling stock will be able to move at the same safe speed. So you need to change that. Safe speed on the curves, it is going to be dependent on the gauge, it is dependent on the radius and the super elevation. So this we have discussed previously also regarding the radius and super elevation. One another thing which is going to contribute here is gauge. So it is a broad gauge, the speeds can be higher. If it is a meter gauge, then it will going to be lesser. Then transition curve length, because the curve is being provided, this is a circular curve and there is a straight section. Now these two cannot be connected together. So there is a transition being provided here. So this is a transition, this one is straight section and this is a curved section. So what is the length of this transition? Whether this transition has been provided or not, that will also define that what can be the safe speed on this track. Resultant of weight and the centrifugal force. So when you are moving on any of such system that the cant has been provided and there is a wagon which is moving in terms of the movement on the track. So the centrifugal force is acting in this direction and the weight is going down in the vertically downward direction. So what is the resultant of these two? That is also going to give an idea. So here means you can have a component on this direction or your component perpendicular to the surface. Similarly, for weight also this will happen, but then the other component will be in this direction. So, there is W1, W2, there is a centrifugal force P F P1 or P2. Now, so compute this safe speed on the curves. A Martin's formula is there, and this Martin formula is for the cases where the transition curves are being provided between the straight section and the curved section. What it says is that V is equals to 3.65 under root of r minus 6, where V is the speed in kilometers per hour and r is the radius of the curve in meters. In the case of non-transition curves where directly the straight and the curved section has been connected, then this safe speed is taken as 4/5 of the speed being calculated above. So, it is 4/5 of Vs for transition curve. So, if we say this is Vst. Now, this formula has been in use previously, but now it is being changed. A new formula has come up, and this is based on the assumption that the center to center distance between the rail heads is 750 mm. This 1750 mm is on the basis of the gauge plus the rail head width. So, if we say this is a 1676 plus the rail head width, this is 1750 mm is how it is being taken, and this is for us a 52 kg per meter rail section. Here the formula being given is 0.27 under root of summation of Ca plus Cd into d. So, here you can see that the radius is being considered, which is in meters. Apart from that, Ca and Cd, where C stands for cant, A stands for actual, which can also be an equilibrium cant, and this D, this is deficiency. So, this value of Ca or Cd, the Cd value is being defined for the different type of tracks. A constant value is being provided, and these values they are in mm. So, when we consider these values and we put it in this equation, we will get the safe speed V in kilometers per hour. The safe speed on the non-transition curves with cant on virtual transition. So, there is no transition being provided as such, but a virtual transition is being talked. So, what is that? Let us discuss about it. Now, this is a change in the motion of a vehicle from straight to curved conditions takes place over a distance between the bogie centers, commencing on the straight at half the distance before the tangent point and terminating on the curve at same half distance beyond the tangent point. So, you have a tangent point, this is a straight section, this is tangent point, from here the curve starts. So, this is a curve. So, when you are talking about here the bogie movement, what we are considering is that it is a distance between the bogie centers. So, when we are talking about the distance between the bogie centers, we consider that distance, and half should come on this point and half should come here. So, this is one bogie condition and this is another bogie condition. So, that is a center to center distance. So, half of that here and half of that here, and that is how a virtual transition is being talked about, and this length of the virtual transition, then in that case it is 14.785 meters. That is on the basis of the way the bogies have been placed. Now, super elevation or deficiency in cant is gained on this particular length with maximum permissible cant gradient not steeper than 1 in 360. So, whatever is the height which is to be achieved. So, we are starting from here and we are going to achieve this at by this particular length L. So, slowly and slowly this height is going to be achieved, and the rate which is defined here is 1 in 360, that is the maximum level at which it can be attained. As far as possible we try to do it as a flatter condition, and in that case it is 1 in 720. We will be discussing about this rate later also. So, in this case where we have a inadequate length of the transition curve, we have calculated the length of the transition curves on the basis of ideal conditions, but the ground reality is that we cannot provide that much length. So, it means we are shortening the length. When we shorten the length, the other parameters are also going to be affected, and this is what is being talked here. What it says is length is calculated based on the actual cant or the cant deficiency, which is the normal condition with which we are going to do it. The limiting values of the cant and the cant deficiency gradient, as well as the rate of change of cant and cant deficiency gradients, they are considered. So, there are certain rates. We did talk about 1 in 360, 1 in 720. Similarly, there is a value here like 35 mm per second or 55 mm per second. So, that is the rate as a desirable and the maximum permissible rate at which this cant deficiency or cant values can be changed. So, considering this, what we do is that now we have a certain length which is available, which can be provided as a transition curve. So, we consider that and we calculate the speed. So, using the permissible limits and the length, the speed is being calculated, and this speed, it should not exceed the maximum permissible speed of the section. Obviously, it is not going to be more than that because the permissible limits are already being reduced. Now, what is going to be the maximum permissible speed? It is a lower of the three conditions 1, 2 and 3 permissible speed for fully transitioned curves, for non-transition curves with cant on virtual transition, and the non-transition curves with no cant at all. So, for these three cases we will calculate the values, and then whatever the lowest of the three will be used here. Now, maximum permissible speed in the case of high speed sections, whatever the three cases which we have considered above, along with that the last one which we discussed was a length of a transition which is inadequate. So, that is also considered here. So, now we have got 4 cases in this particular one, and out of those 4 cases whatever is the lower is going to be considered as the permissible speed. When we take up the numericals, you will be getting further idea that which value has to be taken and how different these type of speed values can be calculated. Now, record the maximum sanctioned speed on the section from the authorities, calculate the maximum permissible speed on the section based on the cant deficiency. So, we are calculating first the equilibrium speed, then we will calculate the equilibrium super elevation or cant. We will add cant deficiency to that, and then we will calculate the speed using the formula being given here. We talked about this formula, this is a new Indian Railways formula being adopted. Now, calculate maximum permissible speed on the section considering speeds of the goods trains as well as the cant axis, because when you talk about the speed of the goods train, this is lower than equilibrium. So, because this is lower, it means the requirement of cant is also lower, whereas the cant which is being provided is higher, that is where there is a cant axis already there. So, considering these two conditions, then we calculate. CA is calculated based on the speed of the goods train, and then the cant axis is added to it, and again we will be calculating the speed. So, previously we used CD, now we are using CE. So, this was cant deficiency, now we are talking cant axis, but actual cant will remain as such, the radius of the curve will remain as such. Then we are also calculating the maximum permissible width related to the length of the transition curves. So, whatever lengths of the transition curves are there, they are rates. We talked about 35 mm per second, 55 mm per second, or the cant gradient of 1 in 360 or 1 in 720. Based on that, this length formula are there. When we will be taking up the calculation of the length of the transition curve, we will be discussing about that, but here we are talking that how different type of speeds can be calculated, and then out of those which is going to be taken up. For high speed broad gauge tracks, when the speed is restricted due to the change of Kent deficiency exceeding 55 mm per second, it may happen that Kent deficiency is going beyond 55 mm per second, but we cannot go beyond this. This is a permissible limit, the maximum value. So, in that case the Kent deficiency is limited to the values less than 100 mm, and again the speed is going to be calculated, which is going to be lesser than the previous values. Coming to the equilibrium speed back, it gives that if the maximum speed is more than 50 kilometers per hour, then this is 3 by 4 Vm or Vs, means 3/4 of the maximum speed or the safe speed, which we have talked with respect to the formula 0.27 under root of Ca plus Cd into R or Ca plus Cg into R. When this maximum speed is less than 50 kilometers per hour, then it is Vm or Vs, whichever is less. Now, weighted average, when talking about this weighted average, now we are talking about the distribution of the trains with respect to the speed on the same track. Not all the trains are moving at the same speed. So, there may be N1 trains which are moving at a speed of V1, N2 trains which are moving at a speed of V2, and so on. So, whatever N categories or M categories are there, we can have that data, and using that data we can have a weighted average. So, it is N1 into V1 plus N2 into V2 plus Nm into Vm divided by N1 plus N2 plus Nm. So, if we take that, we will get a weighted average value. This is an equilibrium speed here. So, let us look at one of the numerical here. There is a data of the trains running on a track, the speeds are defined. This is 40 kilometers per hour, 10 trains are moving, 50 kilometers per hour, 12 trains, 60 kilometers per hour, 15 trains, 80 kilometers per hour, there are 20 trains, and 100 kilometers per hour, there are 10 trains. So, we are going to have a equilibrium speed which is a weighted average of this data. So, it is N1 V1. So, that means when you talk about trains it is N, when you talk about the speeds it is V. So, this is Ni and Vi. So, we take multiplication of that and divide by the total numbers. So, if take total number of trains as a summation here. So, this is 20, 30, 40, 50, 60, 67 number of trains are there with this profile. So, 10 multiplied by 40, 12 multiplied by 50, 15 multiplied by 60, then 20 multiplied by 80 and 10 multiplied by 100 divided by total number of trains 67 gives us the equilibrium speed as 67 kilometers per hour. Now, let us talk about the restriction schedule, which is the last thing in this particular lecture we are going to discuss. There can be different restrictions: 0 speed, 10 kilometers per hour, 20 kilometers per hour, 30 kilometers per hour or 50 kilometers per hour. The restriction of 30 kilometers per hour when it is being imposed is when 1 meter long slotted fish plate with screw clamps or MS clamps or joggled fish plates with bolted clamps, these are used on a temporary rail joint. And when this temporary rail joint is being created, it should remain in 24 hours watch. Somebody is watching that the trains are moving, so what is happening to that? It should not open out. So, in this case, the restriction of speed is 30 kilometers per hour. Train cannot move more than that. Another is when the sleeper fastenings on the alternate sleepers are loosened before de-stressing is being done. We talked about de-stressing when we discussed about long welded rails. So, when on alternate sleepers, not all the sleepers are being done loosened simultaneously, alternate sleepers they are being loosened. At that point also there is a weakness in the track, the trains cannot move on that particular track with a higher speed, and that is where the speed restriction of 30 kilometers per hour will get imposed. When the shoulder and the crib compaction has not been done or the rail temperature exceeds Td plus 20 degrees centigrade, where Td is what? Td is the de-stressing temperature. Again, if you go back, if you remember, we talked about the various types of temperatures: TO, TM, TP, TD. So, those type of values. So, here we are talking about Td plus 20 degrees centigrade. What are the cases for 20 kilometer per hour restriction? After emergency repair of the fractured rail track, there is a big problem now. So, more restriction is being imposed. So, we are doing an emergency repair doesn't mean that the whole of the track is being changed. After emergency repair of the buckled rail tracks, when the subsequent trains comes and they run, at that point the restriction is 20 kilometers per hour, or on a temporary rail joints where, as we discussed previously, but if it is not under the 24 hours watch, then the speed is reduced further to 20. There we were talking that it is being watched for 24 hours and therefore the 30 kilometers per hour speed was allowed. In case of 50 kilometers per hour, when the shoulder and the crib compaction has been done after regular track maintenance, and during consolidation period when the rain temperature it increases beyond Td plus 20 degrees centigrade. So, compaction has done, the consolidation is going on at that point of a time 50 kilometer per hour. If you remember, we talked about a track consolidation, we talked there the speeds, we talked about the GMT, we talked about the number of days, 2 days, more than 2 days, so on, whichever is earlier, accordingly we have taken. Now, restriction on the stop dead, you have to stop the train or it can be allowed to move at a speed of 10 kilometers per hour. For passing first train after the emergency repairs, you have already gone for emergency repair. So, the first train, first of all it has to be stopped and then it moves at a speed of 10 kilometers per hour. And once it passes, it is observed that it is possible that now there is no issue, then only this 10 kilometers per hour can be increased to 20 kilometers per hour. Then imposing restrictions after maintenance if the rail temperature exceeds Td plus 20 degrees centigrade, which we have been talking again and again. So, this is also a case of a restriction schedule. With this we close our discussion now. What we discussed was the speeds on the tracks, what are the dynamic effects of those speeds in terms of the 3 axes, x, y and z, rotational and the movements along those particular axes. Then we talked about the various definitions. We discussed about how the safe speed on a track can be calculated, what can be the maximum permissible speed under different situations, and finally what is the equilibrium speed. Thank you, and we will be meeting in the next lecture.